Hey guys, welcome back. I'm just going to start jumping right into some examples of the normal distribution. In my previous videos, I discussed this 68, 95. It's really 99.7, but I'm just going to put 99%. It's fine. So what this actually means is that if something is really a normal distribution, then we expect 68% of the data to fall within one standard deviation. And then we expect 95% to fall within two standard deviations, and then 99 or 99.7% to fall within three standard deviations. And the reason why I don't really care too much whether it's 99 or 99.7 is because in the next video, I'm going to show you how to use the calculator so you can get approximately the best approximation you could possibly get. And we're probably going to round to 4 decimals. And so this is just to get us started. All right, so let's read. A 20-ounce bottle of soda has an average of 18.4 ounces of liquid in it. So what this basically says is we know that when we have a soda bottle, it's not filled to the top. So it sometimes is closer to the bottle top, sometimes it's farther away. So it's about 18.4 ounces with a standard deviation of 0.3 ounces. So remember that this here is the symbol mu and sigma. And this means average, this means average, this means standard deviation. When something is normal, I should have written normal here. I'm assuming it's a normal distribution. Then what we're going to do is the following. We are going to draw this normal curve. Sorry about my drawing. I'm going to put 18.4, and then I'm going to add 0.3 3 times. You take this standard deviation and you add it 3 times. So that's 18.7, that's 19.0, and that's 19.3. And then this is symmetrical, so I'm just going to take it away 3 times. So that's going to be 18.1, and that's going to be 17.8, and that's going to be 17.5. If you guys recall the numbers that go in here, this is 34.1%, this is 34.1%, this is 13.5%. And this is, you could just put 34% if you wish. This is 13.5. I'm going to say this is about 2, and this is about 0.5. So the question says, what percent of 20-ounce bottles of soda will have more than 18.7%? I'm sorry, 18.7 ounces. So that's this here. So guys, we can just add this up and this will be 16%, or you can say something else. We know that this right here, a normal distribution is made out of 100%. This here is symmetrical to this here. So that means that this part is 50%, this part is 50%. If this is 34%, I should have put 34%, then 50% minus 34% gives you this highlighted part, which is 16%. If you get these numbers down, then you'll be fine. Next problem. The calories in 3 ounces of French fries is normally distributed with a mean of 210 calories and a standard deviation of 30 calories. So not all French fries have an average of 210 calories. It varies. This is how much it varies by. This is our standard deviation. So what I'm going to do here is I'm going to draw my little normal curve. I'm going to put 210 down here. I'm going to add this 3 times. So I'm going to add the standard deviation 3 times. So that's going to be 240, 270, 300. I'm going to take it away 3 times. That's going to be 180, that's going to be 150, and that's going to be 120. I'm going to just put 34% this time in here. I'm going to put 13.5 in here. And then I'm going to put 2 and 0.5, 2 and 0.5. And remember, this part right here is 68%. This part right here is 95%. One standard deviation, let's get a different color. Let's get a highlighter actually. One standard deviation within one standard deviation is 68%. Two standard deviations is 95%. The question says we expect 95% of calories. We expect 95% of calories in 3 ounces of French fries to fall between what two values? So 95% is two standard deviations. So we expect it to fall between 150 calories and 270 calories. So we expect 95% of 3 ounces of French fries to contain between 150 calories to 270 calories. Because this part here to this part here, if you add it, remember 95% means two standard deviations, okay? One standard deviation, within one standard deviation is 68%. So I hope that makes sense. You have to get 95% between here. So that's what we do in this problem. Next, the weight of healthy 18-year-olds are normally distributed with a mean of 180 pounds. It says normally distributed, so I need to make this bell-shaped curve. And it's 180 pounds, so mu is 180, and a standard deviation of 25 pounds. So I'm going to add it, take it away, add it, take it away, add it, take it away. All right. So before I keep going on and on and on, let's just see what the question says. Well, actually, let's just get into the habit of adding and taking away. So 180 plus 25 is 205, plus 25 more is 230, plus 25 more is 255. When we take away 180, 25 from 180, we get 155, 130, and then 105. Now, what percent do we expect to weigh below 155 pounds? Well, I can't do that unless I put my percentages again. That's 34, that's 34, that's percentage. You guys should put the percent sign. I should not be messy here. And then I have 2 and 2 and 0.5 and 0.5. So we want here, we want expect below 155. So if you add this up, you get 16%. So 16%. Now that's a 0.5 there. You can also say this part is 50%, so take away the 34%, you get 16%. So that's 3 examples right there. I'm going to stop the video, and then I'm going to make another video of some more examples. I hope this is getting much better for you and you're starting to get the hang of this. Come back for the next video.